Good morning, Warriors. This is Mr. Davis. I wanted to bring you week 7. Let's start with some questions to preview this section. And hang on one second. Okay, good. And the first question is, what is the source of most of Earth's heat and natural light? I'll let you think about that question and answer for a moment. So hopefully you got that one right. And remember, just like when we're in class, these preview questions are going to give us something to build on. So go ahead and think them over, see what you really think. I'll give you a chance to kind of go over that idea in your head and see if you can pick the right answer. But if you don't get it right, don't worry about it. We're just going to build on what we already know. So what force keeps Earth in motion around the sun? So we got two choices here, friction or gravity. We know friction is like when we drag something across the floor. That's going to slow things down. That's not going to keep things in motion. So gravity is a pull. Yep. So it's going to be one of those. What force keeps Earth in motion around the sun? And there you have it. How many natural satellites does Earth have? Let me see. We got Dish Network, HughesNet, Channel 21, GPS satellites. Yeah, we got all kinds of satellites. Dozens, right? Wait, hold on. Let's reread it. How many natural satellites does Earth have? Oh, okay. Natural satellites. Well, just the moon, right? The moon is our one natural satellite. A satellite is something that goes around or orbits another object, and the moon is the only natural satellite that the Earth has. What causes day and night? Here's something to think about. Is it the tilt of Earth's axis? Is it the sun moving behind the moon? What? Is it Earth's movement around the sun, or Earth's rotation on its axis? Which of those things causes day and night? Think about it. There you go. What events are caused by the motion of Earth and the moon? So imagine that you're looking up at a full moon in the sky. Why is the moon so bright? Does the moon produce its own light, like a flashlight? Or does its light come from somewhere else? Explain your reasoning. So let's take a step back and see if we can digest these questions. They're not that hard, but they are something to think about. So why is the moon so bright? Well, when is the moon bright? Can we see it in the daytime? Sometimes. Why is that? Does the moon make its own light? I think we know that's not true. Does its light come from somewhere else? Okay. Think those things over to yourself. I'll give you a second. So that's the end of the chapter preview. We're going to move into the textbook. How does the Earth move in space is one of the key things we need to learn about. And the other key concept we want to understand is what causes the cycle of the seasons on Earth. And we'll get into a little bit about what cycles are, like kind of in a more overview type of way. But then we'll get into the specifics of the Earth's seasons too. But let's make sure we're all on the same page. First things first, let's make sure everybody knows how to access all of the materials that we need. So I'll type in Hillview Junior High. I'm just on a regular Google search, and I'll search for Hillview Junior High School. And the first result that it gives me back is the home page for the school. Go ahead and verify that address. Make sure it's .k12.ca.us. But then once you get there, go ahead and click on Hillview Junior High. The next place you want to click in order to get the assignments for this class is where it says Teacher Classroom. Click on Teacher Classroom. Then you can find all of your teachers right here. So go down that list, find the teacher whose assignments you're looking for, and boop, click that. Now, if you're on a mobile device, this is where it's going to get a little bit different. I want you to click on Assignments. So we'll do that. But before we do that, you see this little symbol right here, that little V, looks like a bold V, downward pointing arrow. That symbol, if you're on a mobile device, will be next to my name. So click that down arrow, and it's going to drop down and allow you to select these navigation options. So I want you to navigate over to the assignments page. So click on assignments, and if you're on a mobile device, click next to my name. You'll see a downward arrow. It doesn't appear on this website, but if you're on a mobile app, you'll see it. Click that down arrow and click on assignments. And what you'll see by the time this video is published, you'll see under current assignments, it'll say week 7. Right now it says there are no current assignments because I didn't post this one yet because I wanted to give you the instruction first this time. So click on week 7. For our case, we'll click on week 6. I'll show you some things there. But also below the assignment, you'll see the interactive textbook and the California Focus on Physical Science textbook. So at this time, I want you to take out your textbook and open it up to page 462. So if you have your real textbook, take a second, go grab it, open it up to page 462. And I want you to follow along in the textbook while you listen to this and watch this video. Also, the interactive textbook, we're going to use that in class today too. So let's click on the Focus on Physical Science textbook and on the interactive textbook, and we see we got them both opened up. Let's go to chapter 12. We double click chapter 12, and we want to go to page 462. So I'll take you down there. Here's page 460, 461, and 462. And I want to go back to the interactive textbook. This one's easy to get to. You just double click, and then you can go down the pages. If you want to skip to a certain page, you can just you can just use this slider. Just goes pretty fast, pretty easy stuff. But let's go back to the textbook on page 462. And so this should give us an overview of cycles in general. Specifically, we're going to talk about the sun, earth, and moon system and the cycles that arise out of that relationship between these three objects. But I want to point out to you that in life, there are these patterns that repeat continuously, right, in an order or a sequence. One cycle is each 24-hour day, right? The sun rises in the morning and sets in the evening, right? Day is followed by night over and over. So we're going to look at some cycles that are repeating, and I think we know a lot more cycles. For example, if you wanted to measure, like, say, a year, what point do you start from to measure a year? Well, it doesn't really matter where you start from, right? You can start from your birthday, and then you can, when your birthday comes back around again, then that's a year. You can start from a kind of an arbitrary date, like, say, you have a vacation planned every year or a family reunion planned every year on July 24th. I don't know. You can start from July 24th, and then whenever that day rolls around again, that's a year. Same thing with time for minutes, seconds. You don't have to have a particular starting point. And I think that's important to understanding this concept. So with the seasons of the year, you can hop in this cycle anytime you want. And that goes for any repeating cycle. You can hop into that repeating cycle wherever you want. You don't have to necessarily find a beginning, middle, or end. You can just see that this cycle is repeating. So You can read these. I want you to actually look at number 1 right down here. So it says, after you read about the seasons in section 1, I want you to finish reading this little section right here, and then we'll move on. But go ahead and read that, and we're not going to actually do it, but I want you to think about what we're trying to get out of this lesson. So let's move on to page 464. So on 464, we start section 1. And remember, we have to do our note taking. So you should have your notebook out, textbook out, the interactive textbook. You can have that open in a different window. And remember what we have to do every time we take notes. We're going for those jot dots. So each red heading, we're going to make a jot dot based on it. Each blue heading, we're going to make a jot dot based on that. But we're also going to capture all the key terms or vocabulary words, and those are going to be bold and highlighted in yellow. So the first thing we're going to take a note on in section 1 is going to be the word astronomy, right? We can see astronomy down here, and that's a vocabulary word, so we're going to write that in our notebook. We want to make sure we have our name in our notebook and all that good stuff. And we want to take a jot dot based on that. I'm going to take you back to the presentation in a second so we can learn some of this content together. But before we do that, I want to point out another thing on the instructions. So I'm going to click on week 6 instructions. You'll click on week 7 when it's posted. So when you see this video, you click on week 7. I clicked on week 6 because it's not posted at the moment. But it says, to submit this assignment, send a picture of each page that you have completed to this address. This is super important. I want you to just click on this address and just right click and copy, or you can control C. You can do your control C copy and then control V to paste, or you can do the double click, right click, and paste. Make sure you get that email address right. I've talked to a few people. I'm sure there's more who they think they're sending those assignments over, but you're not. So go ahead and make sure you get that address right. Also, the subject line of your message. Go ahead and put the name of the assignment as your subject line. So the name of last week's assignment was week 6. The assignment we're doing this week is going to be called, or is called, week 7. So in the email that you send me, put the title of the assignment in the subject line. This is super important. I get a report every day of emails that are not being accepted by our server, and I don't have any control over it. And the common theme I see amongst them is they typically don't have a subject line. So put a subject line, make that subject line week 6, week 7 for this week. Make the subject line whatever assignment is that you did. So go ahead and do that when you send your email. Another important thing is for you to have an email address that has your real name. So the district assigned you an email address, and you can go on Clever and find that if you want. But if you don't want to use that email address, then you can change your name and change your Gmail name or make a brand new Gmail. Doesn't matter to me. But when you send your email to your teachers with your work, it's highly important that you go to that profile page, hit edit profile, and make that name that's associated with your email account, make that your real name. So in that field where it says first name, last name, like put in your real name, and that's going to help to ensure that your emails don't get bounced back. Now, if for whatever reason you don't want to, that's fine. But you can go to Gmail and make a brand new email address with your real name, or you can use the one that the district provided for you. But you got to do something to make sure your emails don't get bounced back. Anyway, let's move on. So we took a look at that. Yeah, you can look at the directions for week 7, but I definitely want you to double click this one, and then I want you to copy and paste it so you get that address right. But let's move on. I won't spend too much time on this because some of it is review. So if I'm going a little quick, don't worry. I know you guys seen this already. So we looked at those things, but let's take a look. And we're also on page 464, 465 in the textbook. So here we go. How Earth moves. Earth moves through space in 2 major ways: rotation and revolution. So what does rotation mean? Rotation is that spin, that little spin. Rotation is this line that goes from the South Pole through the North Pole, right through the center of Earth. If you can imagine something going through the center of the Earth and then somebody spinning the Earth, right? So think about like a basketball on your finger or something, or if you were able to stick like a pencil through a basketball, which is not realistic, but if you were able to, and then you start spinning that basketball, how would that thing move? Well, that's called a rotation. Rotation is that spin upon its axis. And that's not to be confused with revolution. So the rotation is this little spin. It's the one that causes days and nights, right? And all right. And revolution is every time the Earth goes all the way around the sun. That's a revolution. So a revolution takes a year, and that's that trip around the sun. And again, we're not worried about start and finish days. And rotation is that day. It's that 24 hours, right? It's that shorter time. So we spin once on our axis every day, and we go around the sun once a year. Earth moves through space in 2 major ways: rotation and revolution. We just said that. So that line through the center of Earth, spinning. This diagram is showing you rotation. So in the textbook, you can find a reference to this diagram that we're looking at right now, sunlight striking Earth's surface. That's on page 468. So you might want to flip back and forth through the textbook. And we see something interesting on this one. I think this is the most difficult slide. The most direct sunlight. So for this, less direct sunlight, most direct sunlight in the middle. For this one, we're going to have to visualize something that's not on this slide, and that's the sun. The sun should be way over here to the left of this diagram. So way down there, as far as you want to go, that's where the sun is, and it's emanating light. And it's the only light in this area in this solar system. It's the only source of light. So that light is hitting this side of the Earth, and it's not hitting this side of the Earth, right? So I want you to imagine those two things, and maybe that will help to kind of clarify this diagram, but I think it's a very useful diagram. So if the sun is way down here, so many hundreds of meters that way to the left, the sun is shining from there, it's not shining on this side. The part of the Earth that's pointed most directly at the sun is going to get the most intense sunlight. Why? Well, that sunlight that's hitting the part that's bulging towards the sun, so we see that the Earth is round, but that part that's facing most directly toward the sun, that's exactly this way, the part that's facing most directly towards it is receiving a more concentrated light within the area that the light is hitting. So the light is actually also hitting here too, and across here all the way up to there and down and around here. But you can see for this area, right, the part that's not near the middle, that's not near the part that's facing the sun, the light is covering more area, right? The sunlight has to cover a larger area. Same here. And if we want to kind of think about chapter 11, we know that in chapter 11 we talked about pressure, right? And what is pressure? Pressure is force divided by area. And we know that light is not causing pressure, but we have to make this kind of connection between those two concepts. This most direct sunlight is a smaller area, but it's the same amount of sunlight. This is a larger area that the sunlight is hitting, but it's the same amount of sunlight. So if you take the amount of sunlight and divide it by the area, right, then you can find the intensity of the sunlight. Same here. Take the amount of sunlight, and these are all the same amount of sunlight, and you divide them by the areas that they cover, right? This is the smallest area. Then in this smallest area is going to be a higher intensity of sunlight. So it's something to think about. Hopefully that can make more sense to you. There's some really good videos on it, but I think the best way to kind of digest this thing is to just kind of think about it. Think it over. Same amount of sunlight, small area. Same amount of sunlight, large area. That's going to be less direct. That's going to be less direct. So as we go around the sun, and this is on page 469, the June solstice is the first part of our diagram. But sorry, before we look at that, let's read the title. It says, Earth has seasons because its axis is tilted as it revolves around the sun. So the June solstice, the north end of Earth's axis, is tilted toward the sun. It is summer in the northern hemisphere and winter in the southern hemisphere. So when we experience summertime in June, the southern hemisphere is going to be experiencing wintertime. And you can see why from this diagram. You can see the sun is pointed most directly at the part of the Earth that's tilted towards it. So this part of the Earth is tilted towards the sun. So in the daytime, North America is going to be it's going to be rotating like this, and it's going to be catching the most direct sunlight. The southern hemisphere is going to be rotating like this, but it's not going to be catching the most direct sunlight. And in fact, in December, the southern hemisphere is going to be catching the most direct sunlight. Why? Because in June, the northern hemisphere is tilted more directly towards the sun. Hopefully we can see that. And in December, the southern hemisphere is tilted more directly toward the sun. So hopefully that makes sense. And then we can see in September and in March, we have the opposite of, well, not the opposite effects. We have some interim effects. We got like kind of the middle ground between June and December is going to be September and also March. They're going to be where neither half of the globe, the northern or southern hemispheres, are tilted more directly toward the sun. They're going to be kind of like in springtime or in fall, which are kind of similar seasons. But anyway, let's visualize some of these things. So we talked about the intensity of sunlight and how a more direct hit causes more heat on you, right? It's spread out less. So the height of the sun above the horizon varies with the season. So in the summertime, in June, we can see that sunlight is bing directly overhead almost. It's kind of on a little curve, but we're getting a nice hit of sun, and it's making us really hot. In March and September, you can see the sun is a little bit lower on the horizon. And then if you want to compare December to June, you can see how much lower on the horizon the sun is in December than June. And this is only true of the northern hemisphere. So if we were looking at the southern hemisphere, this would all be different. But where we live in the northern hemisphere, this is what's going on, and this is what's causing the seasons. Less direct hit, cooler temperatures. More direct hit, more focused sunlight, higher temperatures. so we can do an activity, but I think we're gonna wrap it up. We're not gonna do that activity right now. Maybe I'll come back later on this week and give you a little activity to do. But I think we covered everything. I'm gonna go ahead and post this video, and please hit me up if you got questions. Go on Remind and ask the question. That's a major issue right now, is feedback. All your teachers, including me, we want to be effective. We want you to learn a lot, but it's hard if we're not getting the feedback. So if I'm way off base, if there's something that's not clear, let me know. Let me know right away, and I'll try to get something posted for everyone. Guys, hang in there. I hope everybody's doing okay, and I also hope we get a chance to see each other one more time before this is all over and everybody goes off to high school. So with that, I'll wrap it up, but please ask questions, okay? Bye, guys.